So welcome to today's panel discussion, AOI inspection in an AI world. Inspection has become far more than just defect detection. It's now the intelligent control hub of the SMT line, with AI reducing false calls, slashing NPI programming times, and driving true closed-loop feedback between SPI, printers, and mounters. The eyes and ears of the line are evolving into a predictive self-optimizing system. Here to discuss that this week, we have an eminent panel. I have Michael Zahn on the end. Then next to him, we have Calvin Rigar from ViTrox. And then we have Juan Arango here from PowerMe. So welcome, gentlemen. Thank you for joining us.
Thank you for having us.
Welcome to
Nice. So let's get on with the very first question that I've got for you this week. We're going to look at detection, from detection to prediction. AOI has traditionally been reactive, spotting defects after they happen. How is AI transforming inspection into a predictive closed-loop control system that actively prevents defects upstream? Do you want to start with that one, Michael?
Well, AI helps definitely in this case to arrange things or find the components, find the leads, and helps to recognize all this. Yep. But AI also helps in terms of adjusting the processes. This is a different angle to think about it. It's not only about the inspection itself, it's also about how to improve the whole process.
Yes. Yes. Okay. But I mean, how does it? How is it helping to sort of make things more predictive? Have you got a view on that, Calvin?
Yeah, for the AI applications, of course we can have the inspection trends to be analyzed by the AI, because nowadays we can use the AI to perform analytics, pattern learning. So when the AOI detects some kind of measurement values that is going towards defect that's going to happen, then the AI can feedback before the defect actually happens to the previous process machine, and this will be able to prevent the defect from happening in the first place. So this is how the AI can be used to perform corrective actions even before the defect happens.
Right, okay. And of course, Juan, you know, I guess the earlier you catch the defect, the more money you save, you know.
Oh, absolutely. And the key here is with the connectivity to your mounters, to Calvin's point, you're able to feed back and then fix the process so it doesn't continue to happen, because if not, your AI will continue to find the same defect every time.
Right, right, absolutely. So back to you, Michael. I mean, AI-assisted programming promises to cut NPI setup times dramatically. What advances in data modeling, image libraries, and self-learning algorithms are making plug and inspect a reality?
Well, it definitely makes sense to use AI for a kind of automatic programming. It's helpful, honestly speaking, when you have a library and the library is full of all your components already and every inspection setting is done. The population of the board itself or the programming, it's just a kind of seconds. Automatic programming with recognizing components and stuff makes definitely sense on a kind of automatic programming when the AI is pulling this information and setting up the library. This is basically for us the best point to say we make with the KAP, which is our automatic programming system, we make the library full with all the informations you need to program the next program, but then it's just a matter of seconds to just pull the information from the library.
So it makes it a lot quicker, but yeah, and that's all the more important, isn't it, Calvin? With you know, high mix environment, you know, it's if you're doing high mix, and it's more important to get faster programming time. You know, get these the programs done in 10 minutes rather than having to do it in an hour and a half.
Yeah, you're correct, because for NPI products you do not have too many boards to do the fine-tuning or to do the programming. Sometimes you may even complete the whole production in around 2 hours. So that is why we need to reduce the programming time as much as possible, and to automate a lot of the processes in programming by using AI. This is a very sensible direction, not just for our side, but I think all the AOI suppliers moving towards using the AI to automate the programming, and not just on reducing the time, but also we can see a consistent quality. So even a beginner programmer can have a similar quality as an experienced programmer by using the AI to perform the programming.
Okay. Anything to add to that? Mark?
Yes, to their point, the key is obviously the database.
Yeah.
Some use a golden database that they match to. We don't. And the benefit there is that we are able to program the entire board, because what we do is we tear down the component into body, lead, and pad, and then reconstruct it. And that is allowing us to, for us, a regular 8.5 by 11 size board, if it takes 5 minutes to program, it's a lot.
Honestly speaking, we don't have a golden library. We fill
No,
with
but some do.
we fill up our library with the information from the AI to make sure that when the next board is coming with the same component, we can just pull the information from the database.
Correct.
Because
Right.
this is where we need AI to help us to make it easier.
And the consistency.
But are you
each
taking it? Are you
component.
taking it off of the measurement off the actual a board or a golden board, or are you taking it off of the Gerber?
Datas. We even import the CAD datas,
Right.
and the AI recognize what kind of component is it, and also the bill of materials of the PCB.
Okay. Okay. So false calls have long been the bane of AOI. How effective are current AI models at distinguishing real defects from cosmetic anomalies, and what's been done to continuously improve confidence levels?
Well, AI, in this case, and we call it Smart Review. It's basically a review station which is supported by AI to reduce the operator interventions, to reduce the pass clickings and stuff. And this is something what AI can perfectly do.
Right.
And I guess the important part on that side is how quick learns this AI, because the AI needs to learn the behaviors of the operators first,
Yes.
and then it can make judgment, and this can be giving only a signal to the operator, okay, this I would say pass, or it makes it automatically. Then the operator doesn't see it anymore.
Yes.
This is the question. This makes or helps to improve the time, and the operator can do other things in this time, because it's a precious time. Manufacturing time is precious time, and these guys can do other things instead of just clicking OK.
Right.
Yeah.
Yeah. So if the machine is learning as it's going along and building up a pattern database, it's
Yes.
understanding what
Yep.
the operator does. But it's also very true that humans get tired, and they can make mistakes.
Yeah, again, when we use AI, again, the human factor is being removed over here. So the AI is not replacing the human, but it is helping the human to keep in top form when doing their tasks. So when we use the AI to perform the automated buy-off, so when they buy off the defects by AI, every results will be consistent, and the time taken by the AI to perform the buy-off is much faster than the human. So this is where the AI can help to reduce the number of false calls for the human operator to do buy-off. Additionally, we can see that in the future, we may even see auto fine-tuning by using AI. So this is another area where parameter adjustment can be automated by using the AI to fine-tune. Then moving forward, you will see less and less false call coming up, even without a human to perform the fine-tune. So this is where the AI can also help to reduce the
Totally
false
agree,
call.
Gavin. This is the next step. After having the AI helping it, the next would be that AI is, let's say, changing the parameters on the
Yes.
AOI, or
Automatically.
improving everything in terms of parametering to make sure that you not even get this false call anymore.
So what are you saying? You're saying you're going into sort of agentic AI, where it's actually reasoning, it's taking that information and reasoning and making decisions on its own?
Yes and no. From my point of view, yes and no. The point, give me one.
Go ahead.
Oh, no.
In our case, the approach we took is exactly that.
Right.
That it's going to learn, and then it's going to do the fine-tuning back to the program, and that way you won't have so many. Currently, we just released our AI verification,
Yeah.
and what it does is it identifies what you think, or you're not sure if it's good or bad, and it puts a green dot if it's good, and a red dot if it's bad, and because it's learning, it leaves it blank if it doesn't know. And that's where, but by putting the green, nobody has to go look at those. So by clicking less times, they become more effective, and then that will feed back to the original program. So
Right.
if it was, if they need to change the tolerances, which we all have to do, that's part of the fine tuning. Instead of doing it manually like we do today, AI can do it, and then you get the consistency.
And honestly, this is what things AI can do. AI can help the customer to set the tolerances to improve the throughput, to improve the speed, and to improve or remove operator interventions.
Yeah.
Because we all use SPC
Yes.
analysis
Yes.
to figure out what is right and what is wrong.
Okay. All right. So moving on. We'll, quickly, I've got to get through this because it's getting a bit noisy in here. As inspection evolves into the command center of the SMT line, how are vendors tackling interoperability between the SPI, the AOI, printers, and placement systems to create genuine closed-loop control?
Well, this is what I said in the beginning. AI is really good to support the customers in steering the line.
Yeah.
So, as everybody knows, we have a system where we steer with the SPI, the printer. We have even a system where we can do with reflow AI steering the mounter. And the end of line yield or the end of line AOI is then checking everything at the end. This is where AI can definitely help, and you can reduce the amount of work at the line by far with using this kind of systems, because AI is just checking the parameters, changing the parameters to get a perfect print,
Yep.
or helps to find the errors on the pick and place.
Yeah, absolutely. Okay. Now, I don't think your answers are going to be much different from that, so I'm going to skip to the last question here. And I want you to put your...
He said it very well.
He did say it very well. You said it absolutely
Thank
perfectly,
you.
Michael. Thank you. Last question. I want you to put your crystal ball on, or your look forward and have a look into 5 years ahead and see what do you think systems are going to become? Fully autonomous, self-calibrating, self-programming, and integrated with MES and predictive maintenance? Or will human expertise remain essential to guide the AI?
So I think that eventually the goal is nobody involved.
Right.
In a surface mount line, it's, in my opinion, going to be very hard because you have to replace a feeder. But the connectivity across the line will make everything better, to his point, because you can do the predictability, you can identify, hey, you may want to check this head, that nozzle, that feeder, because the trends follow and we're able to capture where the defects came from, so you can drill down and get deep into the... So you're never going to eliminate, but you're going to make the process better, and thus the engineers will be more knowledgeable because they'll be able to do more analysis.
Yeah, I think you're going to be able to...
It'll be predictive instead of reactive.
Right. Yes, that's a good way to say it. But you'll also, I think you'll also still need a human at the end of the day somewhere, so that if there's some anomaly called out, that they can make a decision on it.
Yeah, that is correct. So for human, it is still an essential factor in the production line. This is because some of the new things or some odd-shaped components that rarely comes, or even some very high confidential components that comes in without any data available in the public. So we need human to do this kind of programming for those components. But of course, we can try to create an AI ecosystem where the whole system, not just on the AOI, but the whole production system can have a self-healing ecosystem. So the line can self-heal and heal itself, correct each process. So you can see the first pass yield for all the machines will be very high or improving by time goes on. And in the end, we will see lower waste produced and better yield in the final result.
Right, right.
Agree totally.
Michael?
But on the other side, another factor we should not follow up in this case. It takes maybe too long. Is the problem is we will reduce the amount of manpower at the lines. No question on that. So we will definitely support these operators, these skilled operators, to do more interesting things instead of just changing some parameters and stuff.
Yeah.
The other part, what we have not talked about, and it will basically explode our time, is the amount, how many skilled operators you get in the future.
Yes.
This is something is a constraint as well in the future in every market, and therefore AI can help here to support those, let's say, lower skilled people to make sure that the line runs with a perfect throughput,
Yeah.
with a perfect quality and everything.
Yeah, yeah. I think you're absolutely right. You know, it's just it's going to be simplified and it's going to be highly automated. But there's still going to have to be one person at least in the factory to make decisions on things. Anyway, gentlemen, we're running right out of time. So I want to thank you, Michael Zen from Koyoung, of course, and Calvin from ViTrox. I'm getting distracted here with the noise in the background.
Yeah.
Start to get the music out there.
I know. Calvin from ViTrox, and of course Juan Arango from Parmy. Okay. Thank you, gentlemen,
Thanks,
and
Trevor.
thank you
Thanks,
to our
Trevor.
audience today for watching.